In a previous lesson, we used this diagram to try to understand why retrieval practice might enhance learning, not just measure learning, but enhance learning. And of course, you'll recall that to learn this association between a cue and a target, a word and its translation, or whatever, we want to try and get that association up into the brain, and to do so without linking that cue to any distractors. So the various study techniques can help us get that, establish that link up in the brain. Retrieval practice is one of the best so far discovered. Apparently, when the brain has to actively retrieve information, the process of doing so enhances the very link between the cue and the target that we want to establish in our act of learning. And it's important to note that apparently that active retrieval is better than just restudying that association. So you see, that's a little bit of a strange finding, because after all, when you just reread the word in its translation, you might think, well, why isn't that strengthening this link up here? The evidence indicates that retrieving the information is superior to restudying the information. So in the remainder of this lesson, I wanted to use this similar kind of diagram and apply it to using concept maps, because that's a common technique, and teachers like concept maps. In fact, we saw in a previous lesson some studies that utilize concept maps and pitted concept maps against retrieval practice, and retrieval practice came out better, but concept maps are still a useful study technique. So we'll see how we might understand why concept maps might help the learning process using this diagram. Okay, so you'll recall this box here is our brain, and we're going to try to get that cue-target association up into the brain. That's what we want, that link between the cue and the target. Now let's see how concept maps may help that process. So the concept map then is a technique where you take the concept, like the cue and the target, but then you also write down other concepts, and then you draw those links, and you map out those concepts and then figure out the relationships between them. So in the case of our cue and our target, what we might be doing here is not only associating the cue with the target, but we're associating the cue with some other concept. Association number 1, we'll call it, and A2 and A3, and likewise with the target. We're going to associate the target with other concepts as well. So we have sort of like a web of relationships here, and the cue-target relation is just one of among several links that we're studying with a concept map. Well, if we were just using flashcards with cue and target, we would try to establish just that single link. But with a concept map, then, what's happening in the brain then is that we've got a web of relationships in the brain that captures the web of relationships on our concept map. Now, why would that help us retrieve the target relationship, so the cue-target relationship? Why would concept mapping help us retrieve the information that we want? And here's the idea. So here comes test time here. We have some cue on the test. But now notice up in the brain, that cue, yes, there is a direct link to the target. That's the very link that we wanted to have established during the learning process. But suppose we can't activate the target with that link. Suppose for some reason that link wasn't well established. Notice, because we did the concept mapping study technique, the cue has alternate pathways to the target. So that if we associated the cue with A2 and A2 with the target, then the brain can, in a sense, use the cue to get at the target through the path of A2. We can associate the cue with this other concept and that other concept with the target. And there are many other routes to the target as well. So you see, the idea of the concept map, or what some call elaboration or deep processing, is that if we want to learn the association between one thing and another thing, the cue and the target, it can be helpful to embed that association in a wider network of associations. And this gives the brain more pathways to try and retrieve the information, the very target that we want during some retrieval process. In addition, while the test might be the same cue that we were studying, what if the test has a different cue, right? It's not the same cue that was the focus of our concept map. It may be something else, but now we have a better chance than if we were only studying the cue and the target. We have a better chance of activating the target because that new cue stands a better chance of being related to some other concept that we used in our concept map. And again, then, maybe we can use that other concept to get at the target of the question. So even when the test question might be different from what we were studying, if we encode the information in elaborate ways with complex webs of concepts, then it's more likely that whatever test question is thrown at us, we're going to have some way to get at the knowledge. And educators have some strategies for achieving what they call deep processing. Elaboration is one of them. So if you really want to sort of learn something well, you want to elaborate the information, and concept maps is a great way to do that. You can focus on the distinctiveness of the information, so the key differences between what you're studying and other things you might know. Another way to achieve deep processing is to make information personal somehow. So whatever it is you're studying, take a moment to reflect on how it's related to you or your evaluation of this information. And then another idea is to make sure you're practicing appropriate retrieval. So you want to study in ways that might be reproduced on the test, and find ways to take the information you're studying and apply it to new situations. A great way to achieve deep processing.